Moving into our last chapter, we're going to start with the algebra functions as well as composite functions. So the algebra functions is just operations with functions, and we've actually been doing this all year. We're just looking at a different notation now. So we're going to be adding, subtracting, multiplying, dividing functions. We just have a slightly different notation where for some difference, product, and quotient, we have the operation indicated within a parentheses with f and g or whatever the function letters may be. So f plus g of x just means that we are adding the function f of x to g of x. Difference will be subtracting the function f of x from g of x. Product will multiply f of x to g of x using distributive property, and then quotient is f divided by g of x. We just have to remember that our denominator in a rational function can never equal 0. So we have to make sure that we include any values of x that would make our function undefined, and then we exclude those from our domain. So let's take a look at applying some of these operations. So again, we've got three different functions here to start with, f of x, g of x, and h of x, and we're going to apply the algebra to these functions. So something I like to do when I start with a problem like this is rewrite it out of the shorthand into the longer version so that I could see how I'm replacing these with the actual functions. So f plus g of x would become f of x plus g of x. This helps me remember that I'm not only just adding the function together, but more importantly, a lot of students will confuse this as being multiplication and then multiply by x afterwards, and it's not what that's representing. This is just a whole representation of adding the function f and g together. So we have f of x is 4x plus 3, and we have g of x is x squared. So we're just adding these functions together and combine any like terms. Since there's no like terms to combine, we write it in the standard notation. We're going to apply the same thing here. We're going to take f of x, and we are going to subtract g of x. Again, subtraction is not commutative, so we want to make sure that we're applying that in the correct order. So 4x plus 3 minus g of x, which is x squared. So we're left with negative x squared plus 4x plus 3. Here we're going to be adding f of x and h of x. So f of x plus h of x. F of x again being 4x plus 3, and h of x is 2x minus 3. So we'll combine like terms, giving us 6x, and the 3 and the negative 3 will cancel. Here we're going to multiply, so we're going to have f of x times h of x. And so we're going to have 4x plus 3 times 2x minus 3, and we'll apply our distributive property, 8x squared minus 12x plus 6x minus 9. Combine like terms, 8x squared minus 6x minus 9. And then we're going to do our division, f over g of x. So we're going to have f of x divided by g of x. F of x is 4x plus 3. G of x is x squared. We would look to see if we could factor or simplify. So factor and simplify, if possible. In this case, we can't, so we'll just leave it here. And then we have to make sure that we identify what x is not allowed to equal. So what we can do is set our denominator equal to 0. The square root of 0 is just 0. So x is not allowed to equal 0. So our final answer is that f over g of x equals 4x plus 3 over x squared, and x is not allowed to equal 0 because that would make our function undefined.